And of course, you know, we didn't have a space shuttle back then. But the thing was modulated, the frequency, this very high frequency of the, I think it was like 800 megahertz to gigahertz, but the modulated frequency, well, that was the transmitted frequency, but the modulation of the transmitted signal was audio.
Oh.
Human voice audio.
Ah.
And I'm sitting there, you know, I really just sat back and I'm looking at the schematics. I'm doing some test points here and there, and I'm going like, who the hell are they talking to up there?
Yeah. So it wasn't just telemetry then. Telemetry would be a much lower frequency, presumably.
So anyway, I got into the system. I got all the drawers, bay drawers pulled out. I got the covers off everything. Schematics spread everywhere. And I'm running some different tests and everything. And then it seemed like there was a relay and an EEPROM, the programmable.
This is where the program is stored. The EEPROM is where the control program is stored for that card.
Right. So it seemed to be in that area. And the first thing I did is I check out all the voltages, of course, you know, troubleshooting, and then the different frequencies, and it would tell you what you should see at each test point. So I checked the clock frequency just to make sure that the CPU was performing at speed, and it was 1 gigahertz. And I'm going like, well, that's impossible. So I took the access panel off of the, what you would call nowadays a motherboard that had CPU in it, and the damn CPU was like this. It was huge. And there were like 2 or 3, it looked like smaller, very large scale integrated circuits on this board. And now you got to realize Apple was coming out with their Apple II Plus, which had a 1 megahertz, 1 million hertz clock frequency.
Yeah.
Around the same period.
Yeah.
Now this was a gigahertz, which is a billion hertz, which is 1,000 times faster.
More. Yeah. Yeah. Yeah.
So, for example, if you've got a 4 gigahertz processor now,
you know, you're a factor of 1,000. So it'd be 4,000 gigahertz now if it was the same, you know, multiplication factor. But yeah, I mean,
oh yes.
You know, we didn't get a 1 gigahertz chip in the white world until 2000. I just checked this, and I think it was 1999 to year 2000 when the 1 gigahertz Pentium came out, you know, for use in our own PCs and that. So, you know, this was a difference of 23 years, wasn't it? Which sort of roughly ties up with this figure that people come out with, saying that, you know, military technology is 20 years or more ahead of.
Well, what most people don't realize, a lot of people don't realize that the government, especially classified programs, have technology that's 20 or 30 years ahead of what's commercially available. The National Security Agency, under the R branch, which is a research branch, owned their own factory where they designed and produced very large-scale integrated circuits and processors. I mean, they could build their own custom chips.
Yeah.
They were doing parallel processing 20 years before you could ever buy anything with parallel processing.
Right. Right.
So basically, you know, it was quite interesting running across equipment that was that advanced, and
you'd not seen this anywhere else in anywhere that you'd worked. Nothing quite as advanced as this.
Yeah.
Right.
No, I'd never seen any type of. I'd worked on satellite communications here, but it was all telemetry. But I had never worked on satellite communications that had. That was encrypted. That was modulated at audio frequencies, which is voice.
Yeah. Yeah, yeah. Well, that's very interesting that it is voice frequencies. I mean, maybe we'll come on to what that might possibly be to do with later. But one of the questions I had, I mean, we'll obviously go on to the quasi-crystals, but before we go on to that, I just thought, when you were holding this board in your hands, and you're testing it all and stuff, I just wondered at what point you began to question things and what the limits of this secrecy were. And obviously in 1998 you came out and disclosed. So was this one of the things that made you think, well, this is, why can't we have this more, for more people have access to this advanced technology? Was it at this point you were thinking that, or was that kind of later, or was it a more gradual thing?
Before that, I knew we had to have secrets and stuff classified so that our enemy, would have our stuff, or would have the best military in the world. So I thought it was, just the nature of the business, so to speak, that governments have secrets, and the bigger the secrets, the more effort they put into keeping those secrets. So it didn't bother me. But at that point, I'm seeing, for example, if you saw a computer that you could just, something like a lapel pin or something like that, and then it communicated directly with your brain or something, if you knew that was available, yet you're sitting there using a desktop computer, it would piss you off, because you're going like, hey, we've got all this advanced equipment, why can't we have it?
Yeah.
So it made me start thinking, it wasn't so much that the computing power of this system was so advanced, it was the fact that they had voice communications going on real time, encrypted with space. Well, you don't use voice communication with satellites.
Yeah.
It's all data.
So
all data.
So it's probably more the fact that you were looking at what the equipment was actually doing, what its function was. That's what made you think, this is a bit strange, rather than the technology itself, kind of.
I wanted to know who the hell we were talking to in space.
Right. Okay.
Think about it. We didn't have anything up there.
No.
Occasionally we'd send some astronauts.
I think Skylab was still going then, but obviously it wouldn't have been for that. So.
No. It's just, that would have all been going through NASA. This stuff was very deep Department of Defense.
Yeah.
Advanced programs, and it just nothing made any sense. It wasn't the type of equipment NASA used. NASA is like the old yellow school bus.
That's right.
The military's either put stuff in production and kept it classified, or they've handed it off to NASA to do further research because it didn't lead anywhere. So NASA doesn't get state-of-the-art, top-secret black program equipment. In fact, the original space shuttle, the F-16 had newer avionics systems than the original space shuttle.
Yeah.
Because NASA just didn't have the budget. The Department of Defense, through their different, the Air Force and Navy especially, control most of these advanced black programs. The money goes to these black programs, and the military controls it. The only exception is when NASA has a satellite or something they want to test in space. Sometimes the Air Force or the Navy will let them take their satellite and put it up in space. But most of the time that stuff goes up through Vandenberg Air Force Base or Cape Canaveral, and it's military rockets, not NASA.